Students will be able to find the volume of known cross-sections. So let's try this one. Let's see. In exercises 3 through 6, find the volume of the solid analytically. The solid lies between planes perpendicular to the x-axis at x equals -1 and x equals 1. The cross-sections perpendicular to the x-axis are circular disks whose diameters run from the parabola y equals x squared to the parabola y equals 2 minus x squared. So this, the 2 minus x squared is the top parabola, and the x squared is the bottom parabola. Now, there's symmetry over the y-axis, so we can just integrate. We're going to integrate from 0 to 1, and we can double this. Now, what we're integrating is we're adding up all of the circles from 0 to 1 that we could possibly draw. And the area of a circle is pi r squared, but we're going to integrate this with respect to x because these circles are stacking up along the x-axis. So let's pull the pi out. And we're still going from 0 to 1, and we need to square the radius. I probably didn't leave enough room for this, but if you take all of, or the function value to the top minus that little piece right there to the bottom function, that would be the diameter, so we'd have to take half of that. So we have 1/2. The top function is 2 minus x squared, and then the bottom is x squared. I just made it. And then we are squaring that. So we have, if we square this, we get 1/4, and then pull the 1/4 out, that's 1/2. So 1/2 pi, 0 to 1 of 2 minus 2x squared squared. Let's FOIL that out. 0 to 1 of 4 minus 8x squared plus 4x to the 4th dx. So we have 1/2 pi. And we have 4x, that was right, minus 8/3 x to the 3rd, and plus 4/5 x to the 5th from 0 to 1. And so we have 1/2 pi. And if we plug 1 in, we get 12/3 minus 8/3 plus 4/5. I guess I got to get these to 15ths. So pi over 2, 60 15ths minus, I guess I could have put this together. What is 4/3? 4/3, so if you multiply by 5 is 20 15ths plus 12 15ths. So 32 pi over 30. So that's 16 pi over 15. In exercises 1 and 2, find a formula for the area of the cross-sections of the solid that are perpendicular to the x-axis. The solid lies between planes perpendicular to the x-axis at x equals -1 and 1. The cross-sections perpendicular to the x-axis between these planes run from semicircles to the other semicircle. The cross-sections are circular disks with diameters in the plane. So if the cross-sections are circles, then the area is pi r squared. But we want the area in terms of x, not r. Well, the radius goes from the x-axis to the circle. And just this piece right there is the square root. If we subtract over the x squared, y would be the square root of 1 minus x squared. So that's the radius right there. That is r. So the area equals pi times 1 minus x squared, because when you square that square root, it goes away. What if the cross sections were squares? We have side squared. Now half of one of the sides is the square root of 1 minus x squared. So that means the entire side is 2 square root of 1 minus x squared squared. So the area now is 4 times 1 minus x squared. The cross sections are squares with diagonals in the xy plane. The length of a square's diagonal is square root of 2 times the length of its side. So let's say the length of a square's diagonal is the square root of 2 times the length of the side. So the side is the diagonal over square root of 2. We'll remember that. Now, half of the diagonal now is the square root of 1 minus x squared, but that's only half the diagonal. So the diagonal is 2 times the square root of 1 minus x squared. Now that's equal to the diagonal over the square root, not diagonal. I wanted to scratch that for a second here. How do I want to? Side is equal to, now this is half the diagonal. So 2 times square root of 1 minus x squared over square root of 2, and that's what I wanted. But the area of a square is still side squared, so I just have to square all this. So first of all, that's going to be 4 when I square this over 2. Squaring that gives 2. 4 over 2 is 2. And then when we square this piece right here, we get 1 minus x squared. The cross sections are equilateral triangles with bases in the xy plane. Well, we know if they're triangles, then the area is 1/2 base times height. And let's see, the area is equal to 1/2. Now, just half of the base is the square root of 1 minus x squared. So that means the entire base is 2 times the square root of 1 minus x squared. And then we have to multiply, let's see, if we drop this down here, if we drop the height, if this is equilateral, that's a 60-degree triangle, or angle. This is a 30-degree angle, so this side is 2 times 1 minus x squared, because we know about 30, 60, 90s. And then this side, the height must be square root of 3 times the square root of 1 minus x squared, because I know if I divide all these by 2, if I make this length 1 times this, then this is 1/2, and there's your square root of 3 over 2. So if we go back to how we had it, like this, square root of 3, that side is square root of 1 minus x squared, then this becomes square root of 3, 1 minus x squared. And now the 2 and the half, they cancel out. When we multiply these two together, we just get 1 minus, oops, I need the square root of 3 in there. It doesn't all go away. Then we have square root of 3 times 1 minus x squared.